As the name suggests, synchronous motors are capable of running at constant speed irrespective of the load acting on them. They are machines with high efficiency and are mainly used in high-precision applications. The constant speed characteristic is achieved by interaction between a constant and rotating magnetic field. Rotor of synchronous motor produces constant magnetic field, and stator produces revolving magnetic field. The field coil of stator is excited by a three-phase AC supply. This will produce a revolving magnetic field, which rotates at synchronous speed. Rotor is excited by a DC power supply, so it acts like a permanent magnet. Alternatively, rotor can also be made of permanent magnet. Interaction of rotor and RMF is interesting. Assume you are giving an initial rotation to the rotor with same direction of RMF. You can see that opposite poles of RMF and rotor will attract each other and they will get locked magnetically. This means that rotor will rotate the same speed of RMF, or rotor will rotate at synchronous speed. Synchronous speed can easily be derived as follows. This means that if one has got control over frequency of the electricity, speed of synchronous motor can be very accurately controlled. But if the rotor has got no initial rotation, situation is quite different. North pole of the rotor will obviously get attracted by south pole of RMF and will start to move in the same direction. But since the rotor has got some inertia, this starting speed will be very low. By this time, south pole of RMF will be replaced by a north pole, so it will give repulsive force. As a net effect, rotor won't be able to start, or synchronous motors are not inherently self-starting. To make synchronous motor self-start, a squirrel cage arrangement is cleverly fitted through pole tips. At the starting, rotor field coils are not energized, so with revolving magnetic field, electricity is induced in squirrel cage bars, and rotor starts rotating just like an induction motor. When the rotor has achieved its maximum speed, rotor field coils are energized. So as discussed earlier, poles of rotor gets locked with poles of RMF and will start rotating at synchronous speed. When rotor rotates at synchronous speed, relative motion between squirrel cage and RMF is zero. This means zero current and force on squirrel cage bars. Thus, it will not affect synchronized operation of motor. Synchronous motors will produce constant speed irrespective of motor load only if the load is within the capability of motor. If external torque load is more than torque produced by the motor, it will slip out of synchronism and will come to rest. Low supply voltage and excitation voltage are other reasons of going out of synchronism. It is interesting to note that synchronous motor has got the same constructional features of an alternator. Synchronous motors also helps in improving overall power factor of the system. That's all about working of synchronous motors. Thank you.